Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, so now we are going to look at an example of the question related to wedges. Okay, so let's look at this question. Determine the smallest horizontal force P required to pull out wedge A. This one, okay, wedge A here, and this is the force P. The crate has a weight of 1,500 Newton. Okay, this crate, okay, 1,500 Newton. And the coefficient of static friction at all contacting surfaces is mu s equals to 0.3. Neglect the weight of the wedge. Okay, so first of all, as mentioned in the previous lecture video, okay, check the link in the description down below. We must draw the free body diagram first. Okay, very crucial. Okay, so let's draw the free body diagram. Okay everyone, now we've already done drawing the free body diagram of the crate and also the wedge. Okay, so how to find P here? Okay, so if we do force equilibrium, okay, the equation, if we want to write down the equation of the force equilibrium of this wedge here, we cannot find P because all of this number here is unknown value. Okay, and B and A is unknown. So which is why we must start from the part that has the value, which is the crate, this one. Okay, so because we have the weight is 1,500 Newton, if we do force equilibrium, total of force equals to 0, then we can find the value of NC and also NB. So before we start, as you can see here, we have a lot of forces here. Okay, a lot of direction. Okay, so before you start writing down the equation, so it is better for you to draw all the forces again, okay, and put it on this point here. Okay, for example, NB, we have NB like this, okay, in this direction. Okay, we have NB, and then the weight, we have this one, okay, 1,500 Newton. Okay, and then we have FB 0.3. Okay, FB is in this direction, 0.3 NB. Okay, next we have NC. NC is in this direction, so NC. Next we have FC. Okay, FC is in this direction. Okay, so this one here will be 0.3 FC. Okay, so when we put everything all together in one place, it will help us, okay, to create the force equilibrium equation easily. Okay, so that we won't do any careless mistake. Okay, some of you, okay, some students tends to forget to write down some of the force. So if that happens, you will make a mistake in your calculation. The final answer will be totally wrong. Okay, so try to draw this one first before you write down the equation. Okay, now we have this, so let's write down the equation. Okay, now we've done, okay, creating these two equations here. Okay, total of fx equals 0, total of fy equals 0. So we have two equations with two unknowns. Okay, so I made a mistake here. So this one is not supposed to be FC. NC is the correct one. Okay, so let's use the calculator, okay, to solve the value of NB and also NC. Okay, so after we use the calculator, then we got the value NB is equals to 1376.15 Newton and C is 412.84 Newton. So now we got the value of NB, and NB is also on this wedge here. Okay, so now we can use the value of NB to find the value of P. Okay, so before we start, so again, to make it easier, please make sure to draw again, okay, to draw again all these forces here on the wedge here, just like this one. Okay, let's draw it together. Okay, now we've done drawing back again this one here. Okay, so as you can see here, we have P, we have NB, we have 0.3 NB, and for NA and also 0.3 NA here. So because we draw like this, so it will be much easier for us to locate, okay, this point here, okay, the 15 degree here. So if you look carefully here, we have 15 degree like this, and A here is along this 15 degree here. So it means that this is our 15 degree. So NA and F here must be 90 degree perpendicular to each other. So means that NA here and also this line Y axis here, okay, this one is also 15 degree. Okay, so when we have this one, it will be much more easier for us to write down the equation of the force equilibrium. Okay, so let's write down the equilibrium equation. Okay, now we've done writing down these two equations here. Total of fx equals to 0 and total of fy equals to 0. So if you look carefully here, okay, for the fx equals to 0, we have the value which is negative p. Okay, but for the total of fy equals to 0, we don't have the value of p, which is why I put, okay, the value of P is this one, 0P, means that no P lah, 0P here. Why I do like this? Because I want to arrange P with P, NA with NA, and the known value with the known value, the known value with the known value here. Okay, I want to do like this. Why? Because when we insert the value in this calculator here, when we insert the value of P here, we can easily select 0, okay, as the value of P here. Okay. Actually, you can solve the value of NA without P here. No problem. But I want to advise you to depends on this calculator here, so that no need for us to do multiple calculation. Okay, we just insert these two equations into this calculator and let this calculator solve it for you. Okay, so let's try to find the value of P and also NA using this calculator. Okay, now after we've used our calculator here, we got the value of P is equals to 453.7 Newton, and the value of NA is 1318.7 Newton. Okay, so when we have this kind of question, okay, please make sure that you draw the correct free body diagram, and also please redraw again, okay, your collect all the forces at the free body diagram there and do like this, okay, and also do like this, so that we can look carefully, okay, about the direction of the force and so that we can create a proper equation or the correct equation. Okay, so that's all for today. So see you again in the next lecture video. Bye bye.